2A part 1 asks you to take this equation and create an equation which is parallel to it passing through this point. So all we need is the gradient, and the gradient must be the same gradient as this equation, so we use 3 for the gradient. We then chuck the 3, I know I'm still doing part 1. We use the 3 and the 4 negative 2, and we put it into y minus y1 equals mx minus x1 and rearrange it to whatever form is convenient. And I went for that one because it was easier that way. Okay. Question 2 says, part 2, says find the equation of the line which is perpendicular to that one, and we've just been talking about what the gradient would be if it was perpendicular, at the point 1, 2. Now perpendicular lines will have a gradient of minus a third. Again, that's an achieved thing to know, that if it's a gradient of 3, we flip it over, gradient of negative a third for the perpendicular, and the point, because the point's 1, 2, we just go, therefore, the equation is y minus, what is it, 1, 2? Y minus 2 equals negative a third x minus 1. We substitute it straight into the same old formula for equations. And if we, this time, I'd multiply everything by 3. Or negative 3, please yourself. Expand that bracket out the right-hand side. Be careful with the signs. And then put everything on the left. X plus 3y minus 7 equals 0. And we've ended up with a general form version of the answer as opposed to y equals mx plus c form, just because of that fraction and it was easier.
So what do you use the y minus y1 equals mx minus x1 for?
Equations. That's the general form of a straight line. That's straight line, yep. Y minus y1 is that formula is the equation of a straight line if you know the gradient and 1 point. That's what you use. And even if you don't know the gradient and 1 point, you work out the gradient and 1 point and then use it because there is nothing else. Okay? For instance, if you're given 2 points, you work out the gradient and then you use that formula. Okay? It's just what you do.
You only need 1 point though, don't you?
1 point, yeah.
So how come the y's got 3y?
Because I've multiplied everything by 3.
So even the y gets 1.
Everything, yeah, you bet.
What's the minus 1 when you multiply everything by 3?
Sorry?
Stays there, doesn't it? Why does it?
This step here,
Yeah, why does that minus 1?
which minus 1? That one?
When you multiply everything by 3 to get rid of it.
Yeah, the right-hand side, the 3 gets cancelled. That's all that happens on the right-hand side. The 3 disappears.
Yeah, and that side becomes.
And this becomes 3 lots of that and 3 lots of that.
Yeah, and why is the minus 1?
And the minus 1, I minus it into the, I multiply it into the bracket, and it makes the minus x minus minus plus. Yeah.
Why don't they simplify it further by putting?
Don't know. The answers, they write well, 3y equals. Now, what they've done is they've effectively used this format, which is the y equals mx plus c form, but they left it 3y. Not sure why that is.
So if we were to simplify it,
I suggest, I think, to be safe, always put it in either of these forms. You shouldn't leave an equation sort of part way between formats.
so
That,
both answers right?
yeah, oh yeah. I mean, obviously this is the correct form for the first one. That's the general form for the second one. But obviously there's an alternative form to that. But yeah, general rule of thumb is y equals mx plus c, or general form, but not a combination, not a variation on the two. Okay. Question number. The merit question in number 2, which is part B. Okay, it says 3 of the vertices of the parallelogram PQRS are P, Q, and R. You're given 3 of them, but you're not given S. Okay, and it says find the gradient of the diagonal QS. So what do we instantly need to work out? PQ, if we're told that there's a this is the merit question 2, part B. P, Q, R, and S is a parallelogram that is that sort of shape. And if we know 3 of the points, P, Q, and R, which is P, Q, and R, and we're asked to work out the gradient of that line, we're asked to work out the gradient of the red line, but we're missing point S, and we need it. So how do we work out point S if we know that it's a parallelogram?
Oh, well, it's equal. All the sides are equal length.
No, they're not equal length, Gilchrist. It's not a bloody square, is it? Or a rhombus. Same gradient.
As the parallel sides, so
You can sort of do it by looking at it. That's how I did it, yeah. So the short answer is this. Now, this is what I did. I just used the space on the page, not that there was much at the top there, to do a little sketch. Okay? And doing a sketch, I really encourage you to draw the diagram that goes with the problem, because in this case, the question says find the gradient of the diagonal, but we don't know what the point is. Obviously we know the Q point, but we don't know what the S point is. So we can't work out the gradient until we've worked out what S is, and this makes it.
So how do you know that it's going to be a parallelogram?
Because it says in the question, it says 3 of the vertices of a parallelogram. They actually tell you that it's a parallelogram, and I don't know where my bloody notes have gone, but this is what I did. P, Q, I just did a quick sketch. Here's my axes. 4, -2 is down here. 6, -5 is even further down. 4, 5, 6, -5, roughly down here. So this is 4, -2, 6, -5, and that's P, and that's Q, and then R's over here somewhere. 12, -3, which is about there. 12, -3. P, Q, R, in that order. And S, to make a parallelogram, doesn't take much to realize that the point we're after is up here somewhere. And that's a terrible position, but if you see what I mean, this and that have to be, I can fix it at least. Let's put it over there. It's reasonably horrible. Come on, over there, that's better. So basically, this, our unknown point, which is S, has to be about here. Now, if it's a parallelogram, then I would have thought that, your gradient thing has to work the same. If I go from this point across, if I go from there across and up to that point, I need to move the same distance across and up to that point. Otherwise, it's not going to be parallel. It's not going to be a parallelogram. So there's no sort of real calculations here. It's sort of common sense. So this guy's at 6, -5, and that's at 4. So that's a shift of 2 that way and 3 up. 2 to the left and 3 up. So this guy, a shift of 2 to the left and 3 up, must take me to S. Otherwise, it's not a parallelogram. That's how I found where S was. I basically used that sort of logic, which is saying they must be parallel. So 2 across to the left, 3 up, takes me to 10, 0. And so S is 10, 0. Now we're halfway there. And that's just understanding what a parallelogram would look like. Now, that's not the question. The question says, what's the gradient? Well, the gradient is the rise over run for the point Q, which is way down here, 6, -5. So if we put our line through here, so there's our Q, there's our S, 6, -5 is there, So therefore, the rise over the run, the rise is the -5. So m equals -5. In fact, it's not -5 at all. It's obviously it's a rise of +5. And the run goes from 6 to 10, which is 4. And that's a 4. So the gradient of the diagonal required is 5/4 for merit. So you can see merit is, again, more than just straightforward, do you know the 5 things that make up coordinate geometry? It's, hey, there's shapes in that sit in 2 dimensions. Some are parallel and some aren't, and there's perpendiculars and so on. And there's an example of having to find a point first before working out what is quite an easy sort of second part. 5/4 or 1 and a bit. Any questions on that? That was solid merit.